with Blade. We advised that transaction with Joby and reEvent as well. So Element One, E1 Air. This is the technology that I was talking about. We have these generation systems that you see in the picture. These are mobile. They're on site. You can move them on site at airports or really anywhere you would like. And it converts methanol into hydrogen in a process that one of these slides goes through. I'm not a scientist. Maybe I should start off with that, or an engineer, but I do know a bit about this technology. If you guys do have really specific scientific questions, I'm sure I can get the answers for you at a later date. So Element One is the, stand over here so I can read. Element One is the license holder or patent holder for the technology. They have a number of different licensees that are focused on different markets. So just like we're for aviation, there is E1 Marine that's focused on the marine sector, Kaizen for the transportation, and so on. So this is sort of where we fit in. Nexa and Element One, it's a 50-50 sort of joint partnership for E1 Air. So why do we need hydrogen, affordable hydrogen at airports, especially right now and in the future? That's sort of what we're going to be answering today. Right now, there is a big problem currently with electrical capacity at a lot of the major commercial airports. So you may think, well, that's not really a big deal. They're not really charging anything, but they actually are. There's a lot of electrical ground support equipment today that are battery powered. So think the tugs, all of the conveyor belts, the pushbacks. A lot of these airports use electrical ground support equipment, and those things need to be charged. And as more of the fleet of ground support equipment is transferred over into battery powered, it's more and more taxing on the airport's power supply. So our solution fits right in. It's sort of plug and play, ready to go, turnkey. We can provide power on site. There's also a problem where these bottlenecks form because there are too many vehicles that need to get to too few power outlets, which is a physical constraint that we can overcome because we are a mobile solution. Sorry, we have to, here we go. Okay, so this is the general process of how our technology works. Starting from left to right here, the sort of starting solution is a mixture of methanol and water. That methanol is then heated and then passed through a membrane that on the other side produces hydrogen and water vapor. So it's a simple process. It doesn't require a lot of power. Once the unit gets up and running, it doesn't need to be connected to the grid. So if you do have a portable battery solution for just the startup, you are technically an off-grid power solution as well. Once the hydrogen is produced, which got a slide maybe later on, but that hydrogen can be used directly as a fuel source that can be put into vehicles, or it can be put through a fuel cell to generate electricity. This is the big reason why this solution makes sense. The biggest problem with hydrogen is the transportation of that hydrogen. It's very costly. What this solution offers is you are no longer required to move hydrogen really at all. What you are moving is liquid methanol, which is a liquid at room temperature and room pressures. So it's a very common chemical. It's most commonly used in windshield washer fluids. So it's something that is readily available. And we'll get into this a bit later, but there's everywhere, everything from gray methanol to blue methanol to green methanol. So there is even a completely green and clean solution for the feedstock. So I'm going to get into sort of now the advanced air mobility side of things. We're going to go back to the E1 Air solution after I've sort of identified what the markets are for this. So like I said, on the left side, today's demand, there's a large demand for these electrical ground support equipment vehicles. But it's not only those, it's also electrical rental fleets. So Hertz, for example, who actually just, I think they canceled a big order of Tesla vehicles, and that was most likely a cost issue, which this is a solution that could have potentially overcome that barrier. But then tomorrow's demand is going to be these future, not so distant future, eVTOL aircraft, which are electrical vertical takeoff and landing. Just a show of hands, is this room familiar with eVTOLs at all in advanced air mobility? Okay, 50-50. That's good. I'm going to go over a bit about what that is. So for advanced air mobility is just what I sort of explained. It's using these new electrical or hybrid or hydrogen powered aircraft to move people in and around and between cities in the routes and markets that conventional aircraft are really not able to meet the demand for a number of reasons, whether it's helicopters or fixed wing commercial flight. So we've got a lot of use cases here. There's on-demand air taxi. So if you remember, Uber was big into this. They since backed off, but the industry kept going forward. There's a lot of medical use cases, cargo. There's really just sort of endless, anything that you need to move from point A to point B quickly, whether it's people or things, there's a use case here for advanced air mobility. And then it's not only eVTOLs, it's also UAS, so small drones, really any use case. And what we've been learning recently over the last 5 years is the number of use cases for drones is really limitless. Every day there's a new sort of company that pops up that has a great idea for how to use these things. But it's not only the vehicles, it's also the ground infrastructure. So when we talk about advanced air mobility, maybe the early adopter of a lot of this flight will be the regional airports. I think it's over there, as a sort of existing infrastructure that's there that you can utilize to take off and land. But the problem with that is that it's not necessarily optimally located. So a lot of new vertiports may need to be built out in the larger metropolitan areas, but those are sort of what's being built out right now or studied to be built out. And then the sort of second side of the infrastructure is the low altitude air traffic control. So the conventional, the FAA, for example, the way that they do things is not compatible with the altitudes, the volumes, the trip lengths of these eVTOLs. So what the sort of presiding opinion is that bespoke, smaller networks and ATCs are going to have to be stood up in these networks in order to sort of oversee all of the operations. So our subsidiary, UAM Geomatics, we provide a forecast for advanced air mobility. We've analyzed, I think, around 100 different metropolitan regions around the world. It's a global study. We have subscribers such as state governments, eVTOL manufacturers, helicopter operators. It's a pretty wide range. The GAO used our report to inform Congress back in 2022. They really looked deep into our numbers and our methodologies to try to understand if it makes sense, and they found that it did. So to understand what the potential is for advanced air mobility, you have to sort of start with what's already there. It's an industry that could easily balloon in cost, and you want to reduce that cost, and you want to be smart about how you deploy the infrastructure. So that starts with an inventory of the existing infrastructure and networks that are in place today that can be utilized to also understand the markets that should be sort of the first adopters or first ones targeted by these eVTOL operators. So our analysis looks deep into the price sensitivity of each one of these locations. We have a number of different use cases that you see. That doesn't work, but in the second box here. So we look at emergency, airport shuttle, air taxi, regional campus, business aviation, and cargo. That sort of set is continually expanding. And then what we do is we sort of do a bottom-up analysis where we build out the infrastructure and identify what price sensitivity for each one of these locations is really the sweet spot for balancing infrastructure availability and demand. So it's based on ticket price. And then for some of our projects, which I'll get into the Virginia study that we did, we go one step further and we do an actual economic impact analysis using InPlan. So we can identify job creation, tax revenue, all of those things that oftentimes state legislators are very interested in. Skip over that. So when we talk about infrastructure and the cost that goes into these different pieces of infrastructure that we forecast, there's a lot that has to go into each one of these, whether it's a vertiport or a network operations center or a NOC, basically a remote tower capability. There are studies that have to be undertaken. There's the physical equipment that needs to be purchased and depreciated, as well as staffing and maintenance. So utilizing everything that I just described, back in 2022, we conducted a statewide study for the state of Virginia with VIPC, who I think I saw some VIPC people here, but this was a report that I strongly recommend you guys read. It's a Virginia-focused report. It looks at the entire state. It looks at what the potential is for advanced air mobility in each one of the different regions that we looked at. And it goes into all of those things that I described. Number of vertiports that would most likely need to be required, and so on. And a point on the vertiports, just tying it back into E1 Air, we don't really know what configuration a lot of these aircraft are going to be. Some of them are purely battery. Some of them are purely thrust powered, so there's no forward lift capabilities. And so there's not a lot of efficiency. You have to charge on both ends, basically. And so the charging requirements for some of these vehicles is very large, especially with the battery densities that we see today. The technology that E1 Air offers would be a great capability for a vertiport that's maybe not strategically located near high voltage power. It's very costly to run high voltage. In some areas, it's cheaper in others, but this technology would offer a sort of ready-to-go solution for recharging, as well as the hydrogen refueling. So for Virginia, we were asked to do a number of things. We were asked to inventory the state from a GIS perspective, interview stakeholders, and then conduct the forecasting and identify both the supply chain logistics. So what is in this state that can be utilized from a supply chain standpoint, companies, manufacturers, things like that need to be sort of informed and involved. And then we took the forecast data, ran it through our system with InPlan, and produced our forecast. Yeah, this was our team. We worked with George Mason, so I'll skip over that pretty quickly. So what we found that Virginia is ripe for advanced air mobility. There's a lot of existing infrastructure that currently exists for advanced air mobility to be a sort of a good early adopter in this state. One of the most important factors was the inventory of regional airports in Virginia. Virginia has one of the best networks of regional airports. They're strategically located. I think back in the 40s and 50s when they built a lot of these out, the idea would be that something like advanced air mobility would be taking place just with conventional aircraft. So they decided to build out a lot of these airports with a good sort of capture basin all over the state so that you could fly really anywhere you wanted. We found some of the top use cases for drones, but this is the economic impact analysis. So we forecasted that there would be, this is direct actually right now. So $8.6 billion. This is a forecast between 2023 and 2045. So we forecasted $8.6 billion in ticket sales across the state. That's it may sound large, but it's really if you think about it in terms of volumes and you compare it to commercial aviation, we're talking less than 10% of the volumes of commercial aviation on the outer years. So it's really not a darkening of the skies with these vehicles. It's a great opportunity, but it's within reason. So with the CapEx, we've got a number of items that you see there. The ground infrastructure, so you can build out, according to our study, the entire network of vertiports for around $300 million. So this is a technology and a transportation system that has a great return on investment when you talk about the cost. So oftentimes a highway flyover can cost $5 to $10 million. For that same price, you could build 2 or 3 different vertiports, depending on their size, and strategically locate them so that you don't have a lot of the same volumetric issues that you do with highways. This is our ticket price forecast. So you can see there's an upper and lower range, obviously with distance and a number of different factors, but ticket prices do fall precipitously and then sort of level off. There's a number of reasons. Flight automation is one of those. Battery enhancements is another. As we progress with the technology, we're able to drive costs down. We found that advanced air mobility in the state of Virginia can produce 17,500 permanent full-time jobs. That was a number that the governor was very interested in when he heard about this. It's an industry that is high tech. These are high paying jobs, high skilled workers, and it's very exciting. And then tax revenue, but it's not much interest, I don't think, in this room. So for the GDP impact, the economic impact assessment, all the way up to $12.5 billion of GDP impact over the next 20 or so years. So it's a pretty substantial opportunity. So then we've also looked at a number of different locations, states, cities in the United States, and the opportunity is very large. Right now, we're looking at 14. Oh, this is kind of we're looking at a large opportunity here, which is the point going back to what is the market for hydrogen at airports? It's right here, and this is there's a number of aircraft that do use direct. They have hydrogen on board, whether it's a hybrid electric or direct combustion of that hydrogen. there's a number of different variations that use both, but even with the electrical charging, the use case is there. So E1Air, our technology can do both of those use cases. Like I said, it's containerized, it's mobile, it does power generation. So you're able to have a plug right there ready to go. A number of plugs. There's different sizes of these units. So there's a varying number of voltage and power generation capabilities within these. But it's dual purpose. So even though there's no direct hydrogen refueling requirement or demand right now at these airports, you can use these containers as electrical generation until that time that somebody does need hydrogen, and you can produce the hydrogen from that container whenever you'd like. So this is how it works, basically. So we use a mixture of methanol and water that's pre-mixed. It goes into the reformer, it gets vaporized, and then purified through the membrane. The water vapor, it gets, the exhaust gets burned and then dropped out the top, but it's just water and air. And then you're left with hydrogen that can, if you'd like, you can run it through the power cell, the fuel cell, to produce electricity, or you can just use the hydrogen as a fuel source. So methanol is a very common chemical. It can be produced from a number of different feedstocks. Like I said, it goes all the way from gray up to green. They're all available today at varying costs. Green is more expensive, but gray is oftentimes almost worthless. So you're able to, it's sort of a byproduct in a lot of different manufacturing capabilities. So natural gas, for example, is a big producer of methanol. The process of producing the natural gas also, as a byproduct, produces methanol. Methanol is cheap, so you're able to use it as a fuel stock today in its gray or blue state relatively affordably. So you're able to use hydrogen or get hydrogen for a decent cost versus going right now, if you're in California, I think you're paying $30 or so per kilogram at the pump if you have a Toyota Mirai. So our analysis shows that we can produce it for around $5 per kilogram. So it's a substantial savings. And that all comes from the transportation and storage of that hydrogen. This is the forecast for green methanol through 2029. So right now it's relatively small. The demand for green methanol is not something that historically has really been interesting to the methanol industry. But as these new technologies come out and the hydrogen use case is made more sort of pushed to the forefront, the investment dollars have been made into increasing the supply for green methanol. So if there are companies that are more interested in the green aspect rather than just the cost savings of the hydrogen, the solution lies in the next few years. And that's a capability that's being built out all around this country. In Europe, there's already a pretty good supply of green methanol. But in the US, we're lagging behind a little bit, but it's coming. So these are the sort of different hydrogen options. We've got our solution in the first box. Then you've got your electrolyzer, which is electricity and water. You're cracking the H2O molecule to produce hydrogen. It's a very energy intensive process. So there's a lot of problems that comes with that. And your yield is rather low. if for example, that solution is great if you have a windmill right next to you, because you can just use that energy to sort of electrolyze and produce your hydrogen. But oftentimes you don't have that. So this is sort of a solution that works separately. So ammonia is a similar chemical to methanol in that there is hydrogen stored inside of it that you can extract. But ammonia is a sort of a more dangerous chemical. There's a lot of problems that comes with it, and the efficiency yield is much smaller. And then the last two are just compressed and liquid hydrogen themselves, which it all comes down to the transportation and storage. Methanol is a very small molecule, so it wants to get out and escape from everything that it's held inside of. So that means you have to really build your containers, and the going idea right now is pipelines. You have to build them, and they're to a very high degree of efficiency so that the hydrogen molecules don't escape and it's safely transported. So we're partnered with Emreformer. They're our manufacturer. They're based out of Spain. They are traditionally a auto parts manufacturer, so they're pretty familiar with the processes. And this is our CPG 150. So there's some specs here. I'm, again, not an engineer, so it's this material will be provided to you guys. But you can also go on our e1air.com website and you can read all the spec sheets of the different solutions and products. So this technology, it's clean, it's on-demand energy, it's cost-effective, especially when you're constrained by your electrical supply or your requirement for hydrogen itself, which today is very limited, and it's also portable. So that's a big bonus for these airports that they don't necessarily want you setting up a permanent fixture on their tarmac. It's sort of a requirement that these things are able to be moved around. So I've gone over a number of these, but just to hit these home. So this is a proven technology. It's in use today. I guess I should have said that. So a number of the different licensees have these generators deployed and functioning today, namely the E1 Marine Space, as well as E1 themselves. They have a big unit that they run in their plant in Bend, Oregon. And the methanol is everywhere. You can order it online. You can get it at Walmart. It's something that's safe and people are relatively safe. Can't drink it, but it's available, and it's a solution that can be quickly implemented. So that's it. That's our E1 Air technology, as well as the sort of advanced air mobility. I hope you guys learned something, but I'll take any questions that you guys might have. Yes.
Can you speak a little bit to the business model for E1? Are you selling these units? Are you leasing them?
Yeah, so it's a subscription basis. So we charge, let's say an airline wants to deploy these so that they can charge their ground support equipment. Right now, that's really our only market. So this is sort of our only business model at the moment. But we would charge a monthly subscription, and that allows for a certain allocation of energy, electrical charge. And if you go over that, it's sort of an extra per kilowatt hour.
So E1 would handle the logistics of the methanol at this point?
Yes, exactly. It's a turnkey solution basically for these airlines. Yeah. Yes.
Yeah, I guess kind of similar on that, but do you find having to implement additional safety measures like fire eyes or other ways methanol burns clear, right? So
Right.
same with hydrogen, right?
Yeah.
You have an issue of seeing when there's a problem. So you have to kind of go to great lengths there. So like, do your systems on themselves or in that perimeter? So like, I guess part of that CapEx would be upgrades there, and then
Yes.
I guess instead of having like Jet A trucks come to fill up, there would be a lot more methanol traffic in those airports as well.
There would. So, yeah, there's a couple different solutions for that. So with the fire risks, obviously we'd want to be, compliant with all of the FAA regulations and the airport, regulations. So the idea behind having it containerized is that within that container, you're able to, suppress and contain any potential fires that may, erupt. You are still required to put a sort of an apron around the container once you move it and you have it at a place. You have to erect sort of a barrier on the ground or drive it up onto something, but that's pretty portable. And then what was the second part of your question?
I mean, you're gonna have more. You still
Yeah.
truck it in, right?
Right.
So like, is the idea that those are gonna run on methanol, or is the production of the methanol carbon negative enough that you're using that as a bit of an offset?
Yeah, so right now, methanol is stored in depots at a lot of cities. They have large containers that are sort of already there, often at ports that are full of methanol. So in those locations, it's a quick trip with the truck. There's an opportunity if an airport is really using a lot of methanol, you can site a smaller container at that airport. So that's more of a non-stationary thing, but the trailer or the unit would be able to go to that at the airport, refuel. And because the efficiency of the methanol itself is so high, you don't use up a lot of methanol with the process. So you're at full usage, I think you're refueling one of the CPG 150s every 32 hours, I think. So and that's constant runtime. So, and that can be changed based on the size of the container that you put on the truck itself. But it may run into or create a problem with traffic, but probably not in the near term.
Smaller.
Yeah. Yeah. Yeah.
It's not Logan.
Right.
How many hours have you guys had on your run kind of continuously on one unit, or
yeah,
lifetime? How many hours have you guys run?
That's a good question. I don't know the exact hours, but I know that the Element 1 unit that they have out in Bend, I think it's been running, I don't know continuously, but they initially turned it on maybe 5 or 6 years ago, and it's still running. So I don't know if that's nonstop. I don't think it is, but
Semi-regularly.
Yeah, right.
Well, they just use it for electricity out there?
It's sort of a demo unit. So yeah, they're able to put it through a fuel cell and power their facility, and as well as sort of use that as a hydrogen generation. I don't think they're making any money off of it other than just using it as a demo.
So is the goal for you guys to work again, right? So you'll produce the methanol and it's transported to the airports and then be the deliverers to the units at each airport?
Well, we don't want to get into the methanol manufacturing business, but the transportation of it, most likely we will be involved in that. Okay. Yeah, just logistically, I think it would make the most sense. It does require to be mixed with the water before it's used. So you have to use a fuel mixer. Sometimes the best option to do that is at a separate company that does fuel mixing based on the volumes that you may need. Otherwise, you can mix fuel on site as well using fuel mixers. But depending on which way you go, the logistics are completely different. So most likely we'd have to control that.
Thank you so much, Phil, for speaking. And we actually are going to have a lunch and learn coming up here. So he's going to be back for that panel. We're going to be talking about net zero, myth or reality. So we're going to be talking a lot about sustainability and different energy sources and kind of getting their perspective on things too. So we have Ken Davidian come back, and all of our actually morning speakers will be back for that panel. So take a break for a little bit. If you are coming back, make sure that you check in on the Whova app for the Lunch and Learn, or see a person downstairs to check you in. But take a little bit of break. There's bathrooms, there's refreshments, and then we actually have Chick-fil-A for lunch. But we'll be starting back up around noon, so take a few minutes, and we'll see you in just a few minutes.
Great.
Thank you, guys.
Thank you.